In our study of vectors, you will come across a unit vector at some point. And now vectors, right, we know that they have magnitude and direction, and a unit vector, it still has a direction, but it has a particular magnitude. It has a magnitude of 1. Okay, so its length is 1. Okay, and so an example here, right, we're given a vector and we're wondering if it's a unit vector. Well, if we want to know if it's a unit vector, we need to check if it has magnitude 1, right? So what is the magnitude of v? Okay, use the distance formula, or in this case, this 0.9, right? That is x2 minus x1. So in our distance formula, we can just use 0.9, square that for the x, and then we would add the change in y's, which actually is this negative 1.2. So negative 1.2 squared. And then check, this is going to give us 1.5, and this is not 1. So this is no, v is not a unit vector. Okay, so it isn't a unit vector, and then it said, if not, find a unit vector in the same direction as v. Okay, so all we really want is we want a unit vector in the same direction as v. Okay, and so to do this, what we're going to do is just take v, and we're going to multiply by something. Okay, we're going to shrink it, we're going to scale it, we're going to multiply it so that its length is 1. Well, how do we make its length 1, right? So mathematically, here's what we do. We multiply by, so we want its length to be 1, and so then we divide by the magnitude, effectively shrinking its size. When we divide by its magnitude, we shrink its size. Okay, so to find this unit vector, I would take 1 divided by its magnitude, 1.5, and then multiply by vector v. So this is 0.9, negative 1.2, and then I would distribute this in, right? So we get, at the end of the day, 0.6, comma, negative 0.8, and just to confirm that this is indeed a unit vector, I am going to do the distance formula, so square root of 0.6 squared plus negative 0.8 squared, and punch this into my calculator, and I do get 1. Okay, so this does work. Okay, so to summarize, how did I find a unit vector given a different vector? So the unit vector in the same direction as the given vector, that's what that notation means. We find that by taking the vector we're given and multiplying by 1 over its magnitude. Okay, that's it. Now, that's the general idea of how to find a unit vector. However, I can tell you we actually see two common unit vectors all the time, I and j. Okay, I tells us to go one direction or one unit in the x direction. So if we think about a grid, right, we typically, when we work with a Cartesian coordinate system, we partition, we count by units along the horizontal axis, right? And so all this is saying is that let I be the number of times you step, or the vector corresponding to a step in a unit. So that's vector I. Similarly, we can step in the vertical direction, right? And so every step in the vertical direction, we're just going to use j to represent that step, okay? 0, 1, and 1, 0. And something that's kind of fun, let me do a little bit of a proof. We can actually represent any vector using I and j. So we start with v, AB. And if you need to tune this out, I get it. If you need to skip ahead, I get it. But what I can do via algebra is say that this is A0 plus 0B, okay? And then I can factor the A out, so this would be A times 1, 0, plus B, factoring that out of there, 0, 1, okay? And this is A, and then 1, 0, we just said that that is I, plus B, and then j. Okay, so this says go A units in the I direction horizontally, and then go B units in the J direction, which is vertically. Huh, that seems to be consistent. So we can really just use vectors in a variety of ways. Okay, we can use component form. We can also use unit vectors. Okay, so let's look at these. So it says V and W are given in component form. Write them in terms of I and J. Okay, so V, again, that bolded notation is the same as the arrow notation. So this is saying going -3 in the horizontal direction. I is the unit vector in the horizontal direction, and then go 4 in the j direction, vertically, okay? Similarly, W is going to equal something that you try on your own, okay? Try it, come, and then resume the video when you're ready. Should be I minus j. If you have ones in front of there, that's fine. And then lastly, express 2v minus 3w in terms of I and j. So if it was me, I and j notation seems like a lot of writing to me. So I tend to use it only if I have to. So what I would do is I would actually do the arithmetic in component form. So this would be, -6, 8, plus, I'm distributing, or I'll do subtraction. 3 into each of those, 3 minus 3. Okay, so I get, -9 and then 11, right? So then I do the arithmetic in component form because it's quicker, and then I just include the I and the j at the end. Okay, again, I is just saying go this far horizontally, and then j is saying go that far vertically. And that is all unit vectors, my friends. Okay, so again, to find a unit vector for a given unit vector, just divide by its magnitude. Okay, and just carry that division into each component. And then be aware of I and j, they do pop up in terms of notation, but they're not too bad to work with.